Hello everyone, I am Manisankar from ECE. Today I am going to explain about tunnel diode in modern technology for the case study of physics for electronics engineering. Let us move into the topic. Okay, here you can see this picture. This is the tunnel diode. Let us see about the overview of a tunnel diode. A tunnel diode is a type of semiconductor diode that has effectively negative resistance due to the quantum mechanical effect called tunneling. Tunnel diodes have a heavily doped p-n junction that is about 10 nanometer wide. The heavy doping results in a broken band gap where conduction band electron states on the n side are more or less aligned with valence band hole states on the p side. The application of transistors in a very high in frequency range are hampered due to transit line and other effects. Many devices use the negative conductance property of semiconductors for these high frequency applications. A tunnel diode is one of the most commonly used negative conductance devices. It is also known as Isaki diode after L. Isaki for his work on this effect. So this is founded by the L. Isaki who worked on this effect using tunnel diode. And then the concentration of dopants in both P and N region is very high at around 1024 to 1025 meter power minus 3. The PN junction is also abrupt. For these reasons, the depletion layer width is very small in this. In the current voltage characteristic of tunnel diode, we can find a negative slope region when a forward bias is applied. The name tunnel diode is due to the quantum mechanical tunneling is responsible for the phenomenon, as we already see this in the above page that occurs within the diode. The doping is very high, so at absolute zero temperature, the Fermi levels lies within the bias of the semiconductors. Here you can see the picture of a tunnel diode symbol. This is the tunnel diode symbol, and here it is the forward bias tunnel diode working picture. And then this is the symbols of tunnel diode by representation of using cathode and anode. And then if we move to the characteristics of tunnel diode, when reverse bias is applied, the Fermi level of the p side becomes higher than the Fermi level of n side. Hence, the tunneling of electrons from the valence band of p side to the conduction band of n side takes place. With the interments of the reverse bias, the tunnel current also increases. When forward bias is applied, the Fermi levels of n side becomes higher than the Fermi level of p side. Thus, the tunneling of electrons from the n side to p side takes place. The amount of the tunnel current is very large than the normal junction current. When the forward bias is increased, the tunnel current is increased up to the certain limit. And then when the band edge of n side is the same as the Fermi level in p side, the tunnel current is maximum within the further increment in the forward bias. The tunnel current decreases and we get the desired negative conduction region. When the forward bias is raised further, normal PN junction current is obtained, which is exponentially proportional to the applied voltage. The VI characteristics of the tunnel diode is given. The negative resistance is used to achieve oscillation, and often CK plus function is of very high frequencies. Applications. The applications of these tunnel diodes are these are used in oscillator circuits where the tunnel diodes can be used as a high frequency oscillators, as the transition between the high electrical conductivity is very rapid. They can be used to create oscillation as high as 5 GHz. Even they are capable of creating oscillation up to 100 GHz in appropriate digital circuits. They are also used in microwave circuits. Normal diode transistors do not perform well in microwave operations. So far, microwave generators and amplifiers, tunnel diodes are used. In microwave waves and satellite communication equipments, they were used widely, but lately the usage is decreasing rapidly, as transistors which operate in this frequency range are becoming available. And then if we move to the next one, this is resistant to nuclear radiation. This is an application of tunnel diode. Tunnel diodes are resistant to the effects of magnetic fields, high temperature and radioactivity. That's why these can be used in modern military equipment. These are used in nuclear magnetic resource machine also. But the most important field of its use is satellite communication equipments. That's all from my side. Thank you.